Good day guys, welcome back to another tutorial on probability, and here we are going to treat some of the questions in your lecture notes. I won't be able to treat everything actually, but then with the knowledge of this little you should be able to do the rest. Okay, now the first question is, suppose there are 3 boys, 4 girls. How many ways can we choose a committee of 2 boys and 2 girls? Now this question, remember the idea of permutation, combination, and that factorial with repetition. Remember? Now the question is, we are choosing boys, we are choosing a committee, and remember I told you that if what you are working on doesn't allow double counting, doesn't allow repetition, then you are working with combination. Remember, if you are choosing a committee, now let's assume there is a boy A and there's a boy B. You have 3 boys, and I choose boy A, B, and B A. Still actually the same thing, these two. So since this double counting is not allowed, then I'm using combination. And now let's go straight into the solution. I'm going to clean this layer. I'm going to make this layer disappear. Okay, now you have 3 boys and 4 girls, and you are told to select a committee of 2 boys and 2 girls. Okay, now remember we already said it is combination, so 2 boys and 2 girls, that will be, out of, we have 3 boys, you are trying to select 2, and out of 4 girls you are trying to select 2 as well. Then that should be 3 factorial, 3 minus 2 factorial. I hope you still remember 2 factorial, and 4 factorial, 4 minus 2 factorial, 2 factorial. Okay, that's 3 times 4. Let's still go this way, 3 factorial all over 1 factorial, 2 factorial. Remember, hand is what? Multiplication. Okay, 2 factorial, 2 factorial. Now we have 3 times 2 factorial all over 1 factorial, 2 factorial. 2 can cancel 2 times 4 times 3 times 2 factorial, 2 factorial, 2 factorial. 2 can cancel 2. Okay, so we have 3 times, we have 4 times 3 all over 2 times 1, and 2 cancels 2 there to 4 there to get 2, then 3 times 2, 6. 6 times 3, 3 times 6, 18. So 18 ways, 18 committee of 2 boys, 2 girls can be formed from 3 boys, 4 girls. Remember, I use combination because double counting is not allowed here. And yes, some of you might be thinking, remember I said you have to find out the possible ways. It might be the first boy, the second boy, and yeah, you are right. But remember, remember I said it doesn't allow double counting, and that's why we use combination in the first place. If I say to the first boy, the second boy, the third, then the first girl, the second girl, or it might be the first girl, second boy, no, you are still using the same set of people, It's just that you are just rearranging them, and combination doesn't allow for that. So it's only one of them you are dealing with. So the answer is 18 committee. 18 committee, and that is that. Now let's go to the other question. Now this time around, 1 boy, 3 girls, and I believe you should be able to solve that. Shouldn't really waste much of time on that. Okay, now let's go to the next question. How many 4-digit number can be formed using the digits 8, 4, 3, 5, 9 without repetition? I want to believe you can form that, since we are trying to form 4 digits out of 5 digits. I remember I told you that anything quantitative deals with what? Deals with permutation. That's 1, 2, 3, 4, 5. Permutation 4. How many 4-digit numbers can be formed from this without repetition? So that's 5 factorial, 5 minus 4 factorial. So that's what? 5 factorial. That's 5 times 4 times 3 times 2 times 1, and that is what? 120 ways. 120 ways. Okay, so that is that. That's that. Now let's go to the next question. In a family are 3 boys, 3 girls, 2 dogs, 3 cats. Each evening a party of 3 members go on a stroll. How many parties can be formed? That's the first question. How many parties can be formed? Now remember, you are doing this without replacement. Okay, you have 3 boys, 2 girls, 2 dogs, and 3 cats. Now every evening a party of 3 go on a stroll. Every evening a party of 3 go on a stroll. Okay, how many parties can be formed? That's the first question. How many parties can be formed? Now remember, double counting is not allowed here also, because if you have a particular boy, a particular girl, that same girl, and maybe one animal in particular, maybe the cat, or you pick it as that cat, that same boy, that same girl, it's still the same thing. So double counting is not allowed here. So what do you use? Combination. You got it right. It is combination. So you are combining, you are out of 3 boys, 2 girls, 2 dogs, 3 cats. That's 10. Out of 10, you want to find the number of ways with which you can form a party of 3 people, 3 individuals. So that's 10 combination 3, and 10 combination 3, that's 10 factorial, 10 minus 3 factorial, 3 factorial, and that's what? 10. I believe you can solve the rest. Then let's go to the next question. Okay, how many parties can be formed? We've done that. Now how many of such parties will consist only humans? Now this is a question. How many of such parties would consist only humans? Now remember, you have 3 boys and 2 girls, so if I'm forming this party, how many of them would only be formed using humans, purely humans? Now this time around, the sample space has changed in the sense that the question has exempted the dogs and the cats, so the sample space has changed. Instead of including them, now it is just the humans. So what would that be? You have 5 of them, that's 5 combination 3. How many ways can you select a committee of 3, a party of 3 from 5 humans? So that's 5 factorial 5 minus 3 factorial 3 factorial, and that's 5 factorial 2 factorial 3 factorial 5 times 4 times 3 factorial times 3 factorial all over 2 factorial 3 factorial, and that's 20 all over 2, which is what? 10. So it's 10 possible ways to form a party of 3 humans from them. Okay, now let's go to the other question. How many parties, consisting of only humans? Okay, now there's another question. How many parties, or how many of such parties will consist of humans only with at least one member of each sex? At least one member of each sex. Now this one is a little bit tricky, and I would like you guys to calm down and listen to this part. Now this question we solved the other time is very different from this one we are about to solve now. Very different. Now, how many of such parties will consist humans but at least a member of each sex? Now this is what the question is really trying to say. Let me hide. This is what the question is really trying to say. Now we are forming a party of 3, A, B, C. Now at least it should contain at least one member of each sex. So that means in the first one we want a boy, one boy, then girl, or it should be girl, boy. So at least the party must contain at least one member of each sex. At least one member of each sex. So you have 2 possible ways that can happen. It's either you have boy, girl, or girl, boy. So you have to find probability of doing this. So that's 1 boy out of them, 2 girls, or 1 girl, 2 boys. Now we're going to solve for this. Remember, boys, you have 3 boys, you have 2 girls. Okay, 3 boys, 2 girls. Now solving for this one, remember we are not double counting in this way because they are entirely different. Boy, girl, boy, they are entirely different. So we are going to solve for each of the possibilities. So we have 3 boys and 2 girls, right? Then for probability of picking 1 boy first, that's 3 combination 1, and then picking 2 girls, that's out of 2 combination 2, or probability of picking 1 girl, 2 combination 1, picking 2 boys, that's out of 3 boys you are picking 2. Then we're going to solve for this. 3 combination 1 is 3. Anything combination 1 is that number. 2 combination 2 is 1. Anything combined with itself is 1. That's times 1, or 2 combination 1 is 2. Remember, anything combination 1 is any number combination 1 is that number. Now times 3 combination 2, any number combined with 1 less than itself is the number. So well, these things are things you should know. 3 combination 1 is 3, 2 combination 1 is 2, 4 combination 1 is 4. Anything combined with itself is 1, or anything combined with 1 is like we've already mentioned. But if this number down here is 1 less than the number up, is still the answer is still the number up. And you can, let's just quickly prove that here. 3 combination 2, that's 3 factorial 3 minus 2 factorial 2 factorial 3 factorial all over 2 factorial 3 times 2 factorial all over 2 factorial. It is what? 3. So it's the same thing goes for another one. Let's do 4 combination 3, that's 4 factorial 4 minus 3 factorial 3 factorial, that's 4 all over 3 factorial, and that's 4 times 3 factorial over 3 factorial, and that's 4. Okay, so that's just by the way. Now let's continue. So after doing this, then the answer is 3 plus 6, and that's what? 9. So there are 9 communities that can be formed containing at least a member of each sex. Okay, let's go back to the question. How many of such parties will consist of human animal with more animals than humans? Okay, now this is another question. How many of such parties will consist human animal with more animals than humans? So let's first remember we have 3 boys, 2 girls, 2 dogs, 3 cats. Yes, now we want to form a party of 3, but the animals in it, we are forming a party of 3 including both humans and animals. And remember, the animals should be more than the humans. Now you can do this in 2 ways. You can decide to split it into boys, girls, like that, or you can decide to split it. You can, since they didn't really categorize them based on gender, you can just do it straight as human/animal. I think that's even the best. So we have 5 humans and you have 5 animals. So how many ways can we form a team of 3, a party of 3 having more humans and more animals than humans? So that's what it should be. 2 animals and 1 human. Okay, so since we are picking 2 animals, that's 5 combination 2 and 5 combination 1. Now there isn't any other possibility with which animals will be more than humans. If I pick 2 for humans, then humans are now more than animals. So this is the only way animals can be much more than humans. So that's 5 combination 2, and that is 5 combination 2, 5 factorial, 5 minus 2 factorial, 2 factorial, and 5 factorial. Remember, 5 combination 1 is still 5. 1 factorial. So this is still 5, but this one is 5 factorial, 3 factorial, 2 factorial, and that is 5 5 times 4 times 3 factorial all over 3 factorial 2 factorial, 3 cancels 3. At the end of the day, you have 10 times 5, which is what? 50. So there are 50 ways with which you can select more humans. A party of 3 having more animals than humans. The other way to solve it is when you pick them one after the other. That's, you can pick more animals than humans. It can be a dog, two dogs, a boy, 2 dogs, a girl, 2 cats, a boy, 2 cats, a girl, or it can be cat and dog, a boy, cat and dog, a girl. These are the possible ways, and by the time you find the probability of each of them, you sum it, it should still give you 50. It should still give you 50. So because of time, I am stopping here. I believe with this little knowledge, you should be able to solve the rest of the questions. Thank you very much. I remain Olasunde Faith. Bye.